And today we will have the session number 2, which is the infrastructure of Snowflake Data Warehouse. So without even any further delays, let's start today's session and let's start. Okay, so now what we know till now about the Snowflake Data Warehouse is that it is available as a pre-packaged software. So we can see that it is a pre-packaged packaged software and it is available on the cloud. Okay, so these two things we have to remember. Okay, so because it is available on the cloud, meaning that it is hosted on someone else's computer. So now, for example, if I install everything on my system, if I install Windows, if I install everything on my system, and then I tell you, okay, access my system and then use this software. Okay, so if you want to access my system, then you again do not have to install anything. You can directly connect to my laptop and then you can use that software, whichever is installed on my system. So the same thing is already also happening over here. The Snowflake data warehouse is installed on someone else's machine. Someone else can be anyone. We will talk about this in a moment. So it is installed somewhere on someone else's computer, and that person is taking care of everything of managing, maintaining, installing. Everything is being taken care by that person. And what as a user we have to do is that we have to just connect to that machine through a URL, through a browser, and then we can go ahead. This is a system over here where the Snowflake data warehouse is already installed. Okay. So Snowflake, so I'll mention the full name, Snowflake Data Warehouse. And then when we want to use or access the Snowflake data warehouse, we just need the browser. Okay. So we can access everything through a browser. Okay. There is no other way to access the browser, which we had discussed yesterday as well, that the browser is the only way we can access the Snowflake data warehouse. So we cannot install Snowflake data warehouse on our system. We cannot have it from any other way. We cannot, I mean, this is the only way through a browser. I mean, there are multiple ways. I mean, we cannot also access the Snowflake data warehouse through something called as Snow CLI. We will see that, but majorly the Snowflake data warehouse is accessed using a browser. So now, just like any website, so whenever we want to access anything, for example, when I want to access the google.com, I just have to write something, right? I have to say google.com, right? So to access anything out there in the internet, I need a URL. Okay. So URL is the location where anything is available. For example, if I want to go to google.com, I have to provide the URL of google.com. If I want to go to some other website, for example, amazon.com or your any used YouTube as well. So you have to give the URL of that specific software or that system. Okay. So whenever we create the Snowflake Data Warehouse account, or we can say it to be Snowflake Data Warehouse instance. So instance is nothing but a Snowflake Data Warehouse account. That account is going to have its dedicated URL. Okay. And then through the browser, we have to give that URL to access the system. Okay. So this is what we are going to do. Okay. Okay. So now let's understand what is going on. So we have an account, which is Snowflake Data Warehouse account, and that Snowflake Data Warehouse account is going to have a URL, and then that URL we are going to access using the browser. Okay. So there is a great thing which we have in the Snowflake Data Warehouse. This URL is going to be same for every user who is going to use the Snowflake Data Warehouse. No matter in the Snowflake Data Warehouse, whether you are a DBA admin, database admin, whether you are for example, whether you are a developer, whether oops, sorry, developer, whether you are a AIML expert, AIML user, whether you are for example, you can have any role, right? So no matter what you are trying to do in whatever you want to do inside of the Snowflake data warehouse, you have to come to this URL. Everyone has to come to this URL. There is no other way to enter this box, this Snowflake data warehouse. Okay. For example, you could be a modeler, you could be You could be a modeler, you could be a data scientist, you could be anyone. Okay, you could be anyone. You can be an auditor, for example, right? So whatever role is, whatever you want to do inside of your Snowflake data warehouse, you have to come to this URL. Everyone has to come to this URL, and there is no other way to enter to this box, right? So let's look at it from a perspective of how it happens in the real time, right? For example, there is a party going on in this box, right? So this is a very big party hall where a party is going on, right? And that party hall has a single entrance, right? So everyone, no matter that who that person is, whether that person is the decorator, whether that person is the host of the party, to come inside, there is only one entry point. There is a gate which everyone has to go through, right? So this is the single entry point, which we say in the terms of the application development, right? So there is a single entry point through which everyone has to go, no matter who you are, right? But once you cross this bridge, before crossing this bridge or crossing this entrance, you have to provide your user ID and password, right? So, because for example, whenever you are coming to a party, you will have to show the invitation, right? Not just anyone can enter the party, but to enter the party, you have to show that, okay, you have been invited to this party. This is a private party. For example, we have Ambani's wedding, right? So Ambani's wedding was happening over in some place in this planet. And then no one just, no, just anyone can enter the wedding of the Ambanis, right? So everyone whosoever was invited was allowed to enter through this gate, right? And then no matter who that person is, no matter in that wedding, it was Ambani himself, it was the catering department, it was, for example, he could be a dishwasher person, that could be a event management of anyone, whosoever that person is, that person has to show that that person has been invited to this party. So how they can show that? They have to show their user ID password, which is their authentication. Okay. So authentication is a way through which you authenticate. You say that, okay, I am invited to this place. So let me go inside. Okay. So once you go inside, now you will enter and you will start doing your work, right? So once you are valid person who is invited, then there is something called as authorization. So authorization tells what you are authorized to do inside of this box. Authorizing meaning what you are authorized to do, whether you are authorized to for example, to do the catering, whether you are authorized to meet the family member, whether you are authorized to go to the wedding hall or not. So every person is going to have some authorization. Okay. For example, if there is a beauty, there is a person who has arrived from the some makeup artist has entered this place. So they everyone has to come from here, right? So the makeup artist is invited, so that person can go inside, and then we will have to see what that person can do, what that person is authorized to do inside of this building. That person is authorized to, for example, enter the bride room, right? That lady can go inside the bride room. She is authorized, but she is not authorized. So similarly, she is not authorized to go to the catering room, right? Or the kitchen hall, right? So right now here you can see that every person who is coming to the wedding has some authorization. What beauty about the cloud services or this room, for example, by default, no one can access anything, right? I do not have to tell them you cannot go there, you cannot go there, you cannot go there. By default, no one can go anywhere, and I have to just explicitly say what that person can do. Okay, so over here we have to define explicitly what a person can access, and by default, if I do not give any access, a person a person cannot access anything. Okay. So by default, if any wrong person enters in place of someone else, and that person, okay, has an invitation card, but by default, that person will not have any access to enter anything. So that person will be just sitting outside in the public area or in the reception, but that person is not allowed to enter the wedding hall. That person is not allowed to enter the kitchen hall. That person is not allowed to meet us someone. So that is what we usually see as well when we visit an office, right? There are multiple rooms in an office. When you enter the office, okay, you enter it. For example, if someone has called you to meet someone, right? So let's say you have been invited for an interview to an office, right? So it's a very big office, and in this office there are multiple rooms. There is room one, room two, and in the office, for example, there is room one. That room, in room one, the CEO sits, and then in the room two, for example, the HR sits in the room three, the IT department sits in the room four, we have the auditing team sits. So every room has some, for example, some team is sitting, right? And then if you are invited to an interview, you can enter the gate, you can enter the building because you are invited by someone for an interview, for example, right? Then once you enter, you cannot directly to go some room, right? So by default, you do not have access to any room. You can sit in the open area, or you can see if you can sit in the waiting room until unless someone give you an authorization to enter a room, right? So here you can see that you are authenticated because you are invited, so this is good. You can enter the building, but you cannot do anything inside of the building until unless you are authorized to do that. So by default, whenever we go to any specific room or whenever we go for an interview in a building, so we are told by the receptionist to sit in the waiting area. So this waiting area, you can think of it to a public area, right? Anyone who is coming, who is just invited, that person has to first of all sit in the waiting area. Then, for example, someone will come from the IT room, then that person will come to you, they will meet you, and then that person will help you to enter the IT room, right? So you will have, so for example, if there is any specific access for the room three, then that person will take you with himself or herself, and then you will be authorized to enter the room through someone who already has an access, right? So that authorization can be direct authorization, that this person gives you the tells you, comes to you and in your ear, that that person tells you the password of this room to enter this room, or that person will tell you, okay, come with me, and I will escort you to the room, and then you will do the tailgating, right? So that person will open the door for you, and then you will enter. Okay. So over here we can see that there are two types of authorizations which are happening. Direct authorization, someone gives you the password or the access to access a room, or that person will give you the chance, will open the door for you and will let you enter the room. So that is an indirect authorization. For example, if someone gives you a temporary access, okay, so come with me, and then that is the only way you can come inside. Next way you will not be able to access because that person will not let you. So the similar things happen over here as well. So if you look at the Snowflake data warehouse or any, I mean, any, if you look at any open source softwares these days, one second, we need to, yes, okay, 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 okay. So now the same things happen in the Snowflake data warehouse. No matter who you are, if you want to access the Snowflake data warehouse account, you have to enter through this URL. In this URL, this is a single entry point, and when as soon as you go to this URL, you are presented with a page. You are presented with the welcome page, and then in the welcome page, you will see that you will have to provide the user ID, provide your user ID, and you have to provide your password, right? So if you have the user ID and password, then it means that you are authenticated. And if you provide the right user ID and password, then you can enter this place. And then what authorization you have, that will decide what you can do inside of the Snowflake data warehouse. I am not saying what you cannot do inside of the Snowflake data warehouse, because that is not a thing, right? Nobody by default has any access into the Snowflake data warehouse. You have to get the access required before doing anything into this. Okay. And then now let's look into the next thing. Okay. So what a Snowflake data warehouse actually consists of, right? If we talk about the Snowflake data warehouse, the Snowflake data warehouse is being, you can say that is comprised of three layers. Right? They are very popular whenever you go for sit for any interview in the Snowflake data warehouse. you expect this question. So they will tell you, explain the architecture of the Snowflake data warehouse. So let's understand the architecture of Snowflake data warehouse and things around that, right? So first of all, not first of all, but in the very bottom layer, we have the storage layer. We will see this one by one. So let me first of all complete this. And then above that, we have something called as the compute layer. Yeah. Okay, maybe we can make it like this. So the compute layer, and then over here on the top, we have the um, cloud services layer. Now it is cloud services layer. Okay. So the Snowflake data warehouse has only these three layers which are coming inside of it. So over here you can see that this is how we enter. We first of all, whenever we log in into the Snowflake data warehouse, cloud services layer is the very first layer which we hit whenever we log in. Okay. This layer consists of a lot of things. So let's see what happens whenever we interact with the Snowflake data warehouse and how the query actually works, right? So now let's consider me as a user. First of all, we have seen that the user has to, so first of all, the user has to go or go to the URL of the Snowflake data warehouse. So I'm writing the Snowflake data warehouse as SCW, okay, instance. Okay. So first of all, we have to go to this URL through which you will have to access the Snowflake. Okay. And then we have to provide the existing user ID and password, okay, to tell the Snowflake data warehouse, okay, whether I am the valid user or not. Okay. So once you log in, provide, for example, over here we are, you can say that we are assuming that the user ID and password is right? And then we are good to go. Now we are ready to use the features within the Snowflake data warehouse. Okay. So now based on whatever access we have, whatever we are authorized to do, now we can do it within the Snowflake data. Okay. So now, for example, when we, so for example, over here, we can say that, for example, I am a database developer, right? So now let's see how the things work, right? So because I am connected to the browser, everything, every command, everything which I'll be doing with the Snowflake data warehouse, I'll be doing everything through the browser because the browser is the only way I am accessing the Snowflake data warehouse, right? So now let's say I'm logged in into Snowflake data warehouse. I have entered this building. Okay. So now the very first layer which we hit for the very first time is called the cloud services layer. This is a very important layer. So let's look at the different things which is in there in the cloud services layer. So whether I can, okay, let me do one thing. Let me bring it back to the original state because there are multiple things. So the very first thing which we have over here. So we have seen that first of all, we have to get ourselves authorized. Okay. So over here, we have the very first layer over here. We have something called as the authentication and access control. Authentication and access control. So within the cloud service layer, so this entire box is the cloud service layer. But again, within this, we have multiple layers. So one thing, okay, let me give so that. So now here you can see that this is the very first layer which we have to hit, right? So this is what we have seen. As soon as you give the URL of the Snowflake data warehouse, the very first thing which we have to do is that we have to get ourselves authenticated. Okay, this is the very first step. We have to provide the user ID and password. And this thing is now is embedded as a part of the cloud services layer. Okay, so cloud services layer is the layer which helps us to authenticate to someone else and to the access control. This is the gate. You can say, think of it as a gate to the Snowflake data warehouse, right? And then similarly, we have different people, I mean, different services sitting over here. So we have something called as the transaction manager. So we will talk about all these things. Okay. So let me make it like this. So one second. So we have one, two, three, four, one, two. Let me do it like this. So the very first component, we will talk about these components. Who are these? So we have infrastructure. infrastructure manager. We have some important people sitting over here, right? And then we the next one which we have is, for example, it is the optimizer. Optimizer. We will see what these guys do. And then the next person who is sitting over here. So we have the most important people. The next important people who is sitting here is the transaction manager or transaction manager. Okay. And the next person who is sitting here, who is that person? Okay, like this person, like this. And then the next person who is sitting over here. Oops, not- so this person who is sitting here is called as the security. Okay. Security personnel. Okay. In the front of actual buildings as well, you will see that we already have the security panel sitting over here. We have in addition to that we have these guys. So now let's see what is the function or why these guys are the very first people which you will meet. Okay, so you can think of these people who are sitting in the entrance. Okay, so if we also go to a building, for example, we find that the security guard is sitting there. So instead of so in addition to that, we have some or more people sitting over here. So let's see what is the role of these people, why they are sitting here, and through an example. So the transaction manager, let's give the person. Okay, so now you can think of, so now first of all, you have been authenticated, you have the rights, you can do whatever. Okay, so you are invited to this party. Okay, so for to any wedding hall or any office. Okay, so you can think of it in any way. So you are invited to the party, you have been authenticated, you have the invitation, and then there are four people who are sitting over there. There is infrastructure manager, there is the optimizer, there is a transaction manager, and the security person. Okay. So now so I have entered the building. I can now access this building through this, for example, through this browser, right? So it could be a drone, for example. I've entered this building through a drone, right? And I can also enter this building. I can look what is going on over here. Okay. And now I want to now do something into this building, right? For example, I want to send some food into this building, right? So I have my truck sitting over here. So my truck is here. Now my truck is allowed to enter this building, and I want to send some food inside of this building, right? So now I have entered and I can now send some food. Okay. So I will first of all take all the stuff from here, and then I can send the stuff from here to here. Okay. So similarly, whenever I want to do something in terminology of SQL, I can write some queries, write the queries, and those queries, I can write those queries against the Snowflake data. Okay, so queries can be anything, whether it is like how many users are there, how many tables are there, which table contains which data. So in the MySQL, we have seen that there are multiple type of queries. We have DDL, DML, DCL, DQL. So all these queries are also applicable in the Snowflake data warehouse because it is also an RDBMS. Okay, kind of because it is a RDBMS. So RDBMS stating that this is a relational database management system. Okay. So now again, we will have some data. So we can write these queries once we are authenticated. So now we are assuming that we are allowed or we are authorized to ask question to the Snowflake data. We are assuming, we are saying that, okay, whosoever we are allowed to ask questions inside the Snowflake data. Okay. So this is what authorization we already have. Okay. So now what I will do, once I will logged in into the Snowflake data warehouse, I have been authenticated. This is the very first person who is going to ask you. So if you do not enter this layer, you cannot interact with the system, right? So you have to get yourself authenticated and your access control. So they are the gatekeepers. Okay. So you can think of it to be a gate to the Snowflake data warehouse. Without, if you cannot cross this, no person can enter into the Snowflake data warehouse. And if you want to enter the Snowflake data warehouse, you have to first of all cross this gate. Okay. So now what I want as a user, I want to write some against queries against the Snowflake data warehouse. Okay, against the Snowflake data. So I'll write them queries. So we have seen that it can be any query. It can be create table name, create database, create user, create view, whatever. It could be, so it could be a select statement. It could be update statement, delete statement. So it could be any query. So for now, for simplicity, we are not going into that complexity. So for now, we are saying that whosoever we are. So right now we are assuming that the user is allowed to send any type of query, any query against the Snowflake data warehouse. Okay? Now, this is what we are assuming. Okay, so for example, we have the required authorization to send the any kind of query against the Snowflake data warehouse. And now we write some query, and now we send that query to the Snowflake data warehouse. Okay, so now, for example, we have written some query. We are allowed to write some queries to send some queries to the Snowflake data warehouse, and now we send some query. For example, we will take an example. For example, select star from table A. For example, there is a table in the Snowflake data warehouse, or we can say that select star from employee, where the employee, oh, sorry, not the, where m underscore department, this is the another column, is equals to HR. I want to see the HR. Okay, so now this query will first of all hit the Snowflake data warehouse. So now the next person, because I am already authorized, I do not have to get myself authorized again and again. Okay, so now this query will then hit the optimizer. Okay, what optimizer will do, optimizer knows what is inside of the Snowflake data warehouse and what all objects are there. So the Snowflake data warehouse will not take this query as is, which is coming from the user. It will first of all try to optimize your query. Okay. So for example, this is the query coming from the user. This is the input query. Okay. This is the query which is being sent by user. And then this query, first of all, hits the optimizer. The optimizer sees this query and then thinks of, is there any way I can make this query better? Is there any way? And then what, if you have some specific requirements, and then your optimizer will optimize this query. You can not in the way of the you can see it in English, but how it is going to be executed, for example, right? So internally, externally, it will look same, but it first of all the optimizer parses your query. Okay, so first of all, your query has to be your optimizer parses your query. So the steps, for example, let's consider the steps taken by the optimizer. Okay. So for example, the very first step is that the query is parsed. Okay. So for example, whenever I send some query, and for example, let's consider this table is not there, this column name is not there, or I do not have anything like that. Oh, so first of all, the very first thing which optimizer has to see is that whether these things are there or not, right? So if I'm, for example, if I enter a building, I come to the office, I have been called for an interview, and tell them I'm authenticated, and I tell them that okay, I am here for an interview. I am here to meet Mr. Anil, for example. Okay, and then the optimizer will tell me, Anil, sorry, Anil is on leave today, so please come tomorrow. Okay, so he's on leave, and then I have to go back. Okay, so this is very important. So that is why you see that the query which we are sending to the Snowflake data warehouse, it should be valid. The table name should be valid. So I will see the whatever is passed. The query should be valid. The query should be valid, right? Meaning that the table should exist in this example, right? So the table should exist, and then we should have the columns. The column should exist. Column names should exist, and the syntactically the query should be valid. So the syntax should be valid. Should be valid as well. Okay, we cannot write like select star from employee where the, for example, where the column name is published. Okay. So these things are also cached by the optimizer. Optimizer say, hey, this syntax is not valid. What are you asking me? This doesn't make any sense, right? So over here, these are the important things. So the query is first of all parsed by the optimizer. So that optimizer will check whether everything exists. The table name exists in this example, the column name exists which you are asking for, and then whether this syntax of what you are asking is valid or not. And then the next thing, if everything is good, if the parsing is good, then the query is optimized. This is not optimized, which you might be thinking that okay, it will try to rephrase this thing, or instead of something, it will do something. But the optimizer, it is at the is how the query is going to be executed. Okay. So first of all, there are different plans which are created at the backend. So the query is optimized and the execution plan is created, right? Okay, I'll mention it over here. Or you can say that an optimized plan is created by the optimizer. Okay, so an optimized plan is created. So it is not like a usual thing which you might have seen. The plan will look like something called as, I mean, it is a hierarchical table. So everything which happens, it is actually the output of this optimized plan is a DAG. Okay, just in case if you know, it is a directed acyclic graph. Acyclic graph. Okay. So a DAG is created, and this is, I mean, for example, I'm not saying that this is how it is actually looks like. So here you can see that this starts as a root node. So there is a root node, and then first of all, there is a first of all select statement, and then select statement, it will say that what do you want to select from the table, how that table is going to be accessed, which micro partition it is in. So we will discuss this is all these things in very good detail. So now here you can see that it will tell you which micro partition you have to go, where that micro partition is, how many number of micro partition are there, and then we have the column name, which column you want from that micro partition, whether for that column how many micro partition you have to access, and then for this filter it will check how many micro partitions. So all these things, it is kind of a directed cyclic graph which you can see, which is actually created whenever we go for an optimized query is created. Okay, so it's a DAG which is created. So if you want to go into this deeper, so we will discuss this in the upcoming lectures. So we have an optimized plan which is created by the Snowflake data warehouse. Okay, and everything, all these things are done by the optimizer. Okay, so the optimizer does all these things. Okay, and then once the optimized query is created, so you can think of it like right now we are the only user who is accessing this query or this Snowflake data warehouse. There could be 10 people accessing the Snowflake data warehouse. There could be 100 people accessing the Snowflake data warehouse. So now there should be a person who is taking care of all the different queries in the Snowflake data warehouse and has to make sure that the order is preserved and everyone is served with whatever they are asking without any creating any chaos, right? So for example, there are 1,000 queries coming to the Snowflake data warehouse instance, right? And then someone has to make sure that the order is preserved, right? So for example, if you go to McDonald's, for example, there are 100 people over there, 100 people are ordering something, then the order should be preserved, right? Your order ID should be preserved. For example, if you come over there and you ordered something and the person who came after you got the order before you, so it might, so we become angry, right? So how it is like that person came after me, why he served before me, why I'm not served before that. So I can see that people after me are getting served, but I'm sitting here for the last 10 minutes. Why I'm not served, right? So someone has to be there who has to preserve the order, right? So, okay, there could be an explanation that the person after you who came after you had a very small order. So that is why, sir, that person only asked for water or soft drink. So that is why that person has been served before you. But because your order is very large, so that is why it is taking time for us to serve your order. That kind of thing could happen as well. So now there could be someone, there needs to be someone, a person or a system where the order is preserved. The data consistency should be preserved. Consistency. So we will talk about this, all these things in detail. Okay, must be preserved, right? So oh, sorry, preserved. Okay. Okay. So now there needs to be someone who has to take all these orders, who has to remember that which order belongs to whosoever, whom to who. So you need this person, right? So whenever we go to McDonald's, we place our order, we sit aside, and then there are 100 people who are coming, they are giving their order. Then the person who is taking the order, they have to remember which order belong to whosoever, and then that person has to give that right order to that person. And then if that person, I mean, everything has to be managed by that person. So whosoever is doing this, everything is done by the transaction manager. So the transaction manager is responsible to ensure that everyone who is sending the multiple queries, so the queries order is preserved, the data consistency is preserved, and the correct output, correct result is sent or is returned to the designated person or to the correct person. I mean, to the to its actual actual person or the actual person who is asking, actual user, you can say that, okay, who has asked this question. So it's not like 100 people are asking question, you are optimizing the queries and giving wrong result to wrong people, right? So optimize is not aware of these things. So optimize does not remember who asked which question, how many people are asking this, who is doing what. The transaction manager is telling the optimizer, okay, this query has come from this person, optimize this query and tell me what is the output, and I'll ensure that the transaction is maintained and everyone gets the order on the same time. Okay. In addition to that, we have a person who is security. So security is something you can think of to be an integral part of the authentication and access control. Security also does the same thing. So security also ensures that the data inside the Snowflake data warehouse is also secure. For example, if someone tried to ask some queries which are not valid, right? So sometimes there could be a person who is sending some wrong queries, right? So that person is not sending valid queries, or that person is sending some queries which could create a problem in the Snowflake data warehouse. It could be something like some SQL injections, or that could be that person is trying to hijack or create an issue in the Snowflake data warehouse. So we need to be ensured with that. Okay, it's for example, we can say that a user that is a valid user. For example, there is a person, a user a user sends a query to, for example, to drop all the databases. For example, okay, this is just an example. Okay, so for example, there is a user who has the access, and that user is trying to drop all the databases in the Snowflake data warehouse, or that user is trying to delete all the users in the Snowflake. So these kind of queries, they will go to transaction manager. Transaction manager will say, okay, that's good. You want to do this. Then that query will be sent to the optimizer. Optimizer will try to optimize this query. But before the actual execution of those queries will go to the security. Security will see, okay, see what you are trying to do. You cannot do that. This is just an example, okay? You can actually drop all the databases, but still there are some few queries which some person, if they are trying to execute against this Snowflake data warehouse, the security will also check those queries, which queries are going to get executed against your Snowflake data warehouse, so that no person can send just any kind of query. Okay, you cannot just write any query and then just again the Snowflake data warehouse. That query does not and should not affect the integrity of the Snowflake data warehouse. Okay. And on top of that, we have something called as infrastructure manager. So the infrastructure manager is someone who takes care of the infrastructure, whether the infrastructure is correct or not. If some scaling up is, if someone wants to increase the uh, users, if someone wants to increase the virtual warehouses, if someone wants to increase the storage layer or the compute layer, then we have a user. This infrastructure manager is responsible for maintaining and managing the infrastructure at a very high level. Okay. So that is why this person is. So now we know that what makes sense of this one and why these guys are sitting in the Snowflake data warehouse in the very entry, right? So here you can now very well imagine why these people are sitting at the entry gate, right, and not somewhere else. And these things, what we have just discussed, it is called as the cloud services layer. And okay, I'll place something over here, and okay, that's fine. So now, are we all good? Are we understanding what we just discussed? Any question? Anyone? Am I audible? Sometimes I doubt that whether I'm audible. Hello,
Yes,
hello.
people, you're audible.
Okay. Are we all good? Tejendra, Murli, Pavan, Melia. Hi, Melia. Very good morning.
Yes, sir.
Melia, are we good?
Hello. Yes, I'm good, sir. Thank
Okay,
you.
thank you. Okay,
I had,
Rajguru, Ahmed. Yeah, yeah, sure.
can
I
you
heard.
scroll down a little bit?
Okay, sure. Sure.
Yes, sir. We
Yeah.
are
Okay.
good.
Okay.
What,
Thank you.
can you repeat the part about the directed acrylic graph? I didn't quite understand that.
Oh, okay. Yeah, so this we will see later on. Actually, whenever we send a query, that query is optimized, and that query actually takes the form of a directly acyclic graph. Okay, so this is a tree-like structure. It is a tree-like structure which tells which tells which tells the Snowflake data warehouse how to access the tables, how to access the table data, and from where. From where. Okay, so all these details are embedded into this DAG. So I'll show you one DAG, for example, optimized. Optimized.
So, Vipul, you mean to say that this DAG has the information
Yes, about the
uh,
how to
like
access.
table content? So, whenever we are
Mhm.
searching, this DAG is redirecting us to like which table has what information?
Yes, so now it will not tell us. This is an internal query which is created by the Snowflake Data Warehouse Optimizer. So it looks like this. It is a tree structure. So over here, you can see that first of all, you have to do this, then you have to do this, then you have to merge everything, then you have to do a nested loop join. So in the Snowflake Data Warehouse, we have multiple type of joins. There is, I mean, there we have an inner join, but how that inner join will be implemented in the Snowflake Data Warehouse, there are multiple ways to do that at the hardware level. We are talking at the hardware level. Okay? So how to access the tables, how to join them, which type of join you have to do, when you have to do the sorting. So this is how your DAG look like. Okay. So this is not actually our DAG. This is coming back. So there is no cycle. There is a cycle inside of it. So we will also see this. These are kind of some examples which we can see that this is kind of a graph which is created by the Snowflake data. So this is how a DAG looks. Is this the task service? No, 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 this is not task service. This is something else. Okay. So this is done every time whenever we send any query to the Snowflake data warehouse, a DAG is created. So we cannot see the DAG. Okay. So we cannot see actual DAG. We can see it later on whenever the query is executed. Then we can see that this is a DAG which is internal to the Snowflake data warehouse. This is kind of a language which the Snowflake data warehouse has to generate for its system. Okay. So it actually is at the hardware level. Okay. So how to access the table, where the table is in the hardware, okay, where it is, which location it is, which disk it is in. So you can imagine it if you compare it to your laptop. You can think of it, you just write a query. For example, if I go to command prompt and I say that, for example, ls, for example, okay, ls is not there, sorry. So for example, if I run any query, okay, so even if I have Python installed, so I tell my system that I want to run any Python code. Okay. And then how this is executed, how to go at the hardware level, because everything is in the hard disk, right? So somehow the instruction which I'm asking, they have to convert it to the location of the hard disk, right? So somewhere, someone has to tell my system where the Python is located in my hard disk, because Python is not on my RAM all the time. So someone has to tell my system in the hard disk where that specific table is, in the hard disk where that specific column is, fetch those column from that memory location, and then take it to the virtual warehouses, and then how to process that information. Someone has to tell these details, right? I agree. I hope I now you're able to understand. So someone has to tell these details, how to access the details from the hardware. Okay, so these are kind of these are tree structures which tell us how to get the details from the hardware, how to fetch those details, when to join something. For example, if in a query we saw that, right, there is a specific order in which the query happens. So if I say select star from this table name, where this clause, and then if I do the order by, right? So first of all, the where clause run, right? So for example, so if I say select star, fine. So if I say select star from table employee, where the M underscore salary is greater than 100, and then I say group by, or not order group by, we have to say order by employee department. Okay. So now over here, you can see that we have already seen that there is a specific order in which the things will happen, right? So very first thing, the where clause will run. The where clause, before that, we will have the table name. So first of all, somehow the system has to know where that table is, right? What is the location of the table in the storage, right? In the hard disk or in the RAM, wherever that table, right? It is not it. Someone has to tell, right? What is the memory location of that table, and then after that, someone has to tell, okay, how to fetch that, how much of the data to fetch, how much data is to be fetched, right? Someone has to tell this, and someone has to tell how, which type of filter to apply, which type of filter to apply, or which type of filter to apply. Because for us, there is only one where clause, but in the hardware level, there are multiple ways to do filtration. There are some location, I mean, this is not a part of the scope of this course, but there are multiple type of filters which have to apply, and your Snowflake Data Warehouse optimizer, for example, has to decide which filter is good for which type of data type, for example. A specific type of filter is good for filtering the numeric data. A specific type of filter is good for example, filtering the your character data. Some type of filter is good for filtering the date type of data. So all these things we do not worry about, and we have never thought about it, right? Which type of filter to use based on the data type. For us, it is just a where clause, right? We just write the where clause, but the system has to know what type of filter, how to fetch that data, what type of database is it. So based on what type of data type, there are different type of filters or methods or procedures within the system to decide how to get that data. Someone has to tell that what is the order. Okay, so for now, if the filtration is done, so for example, they have to see how many columns are required, right? So which type of columns are required, and then finally how to display that output, where to display the output, right? How to get the final output, right? And how to display the output, how to display the output, right? Someone has to tell all these things. I mean, this is self-explanatory for us, but someone has to write all this query. Someone has to tell where, what to do, from where to do, how to get it, how to fetch it, from where to get it, whom to hand it over to, who is asking for it, what is the transaction ID associated. So all these steps are written in terms of a tree. So this is how all these queries, this is how all these instructions look like. Might look very strange for you. So this is something, a physical DAG, physical query DAG, meaning that how these things happen at the physical level, right? Not at the logical level. This is how you go to the physical layer. So the physical meaning that your hard disk, okay, how you go to hard disk, how you get that data, how you join that data, how you merge that data, how you do the filtration, how you do the sorting. So all these things, all the instructions are part of something called as, it is written on a tree. So that is why it is called a DAG, and DAG stands for directed acyclic graph. Okay. So we will also have this concept when, if someone of you is aware of the DBT, in DBT we also create that. So that is a very, very important. Is everyone okay? Are we comfortable now? Any questions? Please feel free to ask questions. Okay, I'm happy that you're asking questions. Else I thought that maybe I'm not audible. Okay, I sometimes get confused whether I am audible. Are we good? Melia,
Yes,
Melia, are we good? Rupali,
Yes, we
Yes,
are.
sir.
okay, are you good now? Okay,
People,
so
one question
yeah,
is that
sure.
to log in this thing, Snowflake, right? It's mandatory to have a user any role.
No, it is not mandatory. So this is what we discuss. For example, if you're allowed to a party, and you, by default, you can see that by default we have something called as public role. Okay. So it is like, for example, whenever you go for an interview and you do not have any access, you are asked, called for interview, but you are not allowed to enter any room. So you can sit in the, for example, in the reception area, right? You can visit someone and sit in the reception area. You can be in a building without actually having any specific role associated. Okay, it is not mandatory. We will see that in the part of the authorization, how so here you can see that, right? So by default, nobody has any access, right? They have something called as public access, which we will see. There is a public role which is by default assigned to someone whenever we create any user. But apart from that, that person cannot access it. Okay, so a user can access without any role associated with that. Okay. Okay, good. What was that? Vikas, right?
Yeah, okay.
I have one doubt.
Yeah, Tejendra, sure.
Yeah, like in the cloud services only, we'll choose the nodes and the clusters, everything.
No, that is a compute. This is the only
Compute.
thing which is done in the cloud service layer.
Okay.
This is the, I mean, all the things which your cloud service layer do. This is like the
Okay.
very first layer which you will meet. So, for example, whenever we go to a building, then these are the guys who are sitting at the gate. Okay, so security personnel are sitting there, transaction manager people are sitting there, optimizers are sitting there, and the infrastructure managers are sitting there. Okay. So they actually are the very first point of contact whenever someone logs in into the Snowflake data, right? Are we good? Can we go to the next layer? Shall we move ahead? So now we have something called as the optimized query. So our optimized query is ready and it is a valid query. So one thing which we have, which we now can assume that this is a valid query. This is an optimized query. And then the person is now authorized. This is a secure query and the transaction ID has been assigned to this query. So every time whenever there is a query, there is a kind of query ID or the transaction ID. So this everything has been generated. So a tag has been created and the query ID has been associated to it. And then I mean, you can also say the transaction ID is also associated with it. Okay, so that we can understand who is asking that query. If that person is asking 10 queries, so we know that this is the query ID 1 and this is the directed acyclic graph it has been created for the query. So we have these things ready and now this query is ready to go to the next layer. Okay, so shall we move on to next layer, next interesting layer?
Yes, sir.
Yes, Vipul.
Okay, so the next layer is something called as the compute layer. Okay, so before under that, we have something called as compute layer. So I'll copy paste this, and this is going to be the compute. So now in the compute layer, let us now remove everything and let's have the no border. Okay, and then we also need to, okay. In this layer, we have very interesting person who is sitting over here. So now we have got everything. We have got the query ready. We have got everything ready. We have got the optimized query. We have the query ID. We have the transaction ID. Next, what we want? We want someone who can actually take this directly a cyclic graph or the optimized query and execute it, right? We want someone which is called an executor, right? So let's look at that. We have something called, the name of this person is not executor, but this is the thing which this person is authorized or which this person do. We have, drum rolls please, we have someone called as very popular name which we have in this Snowflake data warehouse. We have something called as virtual warehouses. It's better if I keep it as a single. So the virtual warehouses are those systems who actually do the computations. These guys take the optimized query from the optimizer, and then this is the actual, these are all the actual details. So an optimized query or the directed acyclic graph is created, and then it is submitted to the virtual warehouses. What are virtual warehouses and how they're able to do? Let's now do the dive. So we can say that this virtual warehouse now consists of two things. Okay. So just like your CPU, right? So so now, whenever you look at your system, what all does an executor should have? An executor should have the CPU, right? Or I can say that the executor should have some processing power, right? Or you can say some CPU. And what else an executor should have? An executor should have memory, right? It should have its own local memory, for example, which you can say it in the computer term, we say it as cache, right? Cache. Okay. And then that executor should also have something called as shared memory. Right? It should have some RAM, right? So this is how your system also works, right? So whenever we want to execute something in our system as well, we need a processor. We need every processor has its own memory. And there is also RAM, which is also available as whenever we want to execute something, something has to first of all be loaded into a RAM and then has to be executed. So this is what your virtual warehouse consists of, right? Not everything, but this thing. Okay. So now over here, you can see that the virtual warehouses take up the optimized query plan, which is the DAGs, and then it is responsible for taking all those instructions one by one and executing all these instructions based on whatever those instructions are embedded in your optimized plan. Okay. So now I have So over here, you can see that these are some instructions which are created in the tag. For example, this is instruction number 1, instruction ID 1, and then this is instruction number 2, instruction number 2. Oh, sorry. This is instruction number 3, for example, and then why and then, for example, these are some sequential instructions that have been provided in the directed acyclic graph, and then these have now been given to the virtual warehouses. Virtual warehouse is very smart. It knows how to execute this thing. Okay, so they actually does all these things. They decide a lot of things, and then they know where the location is. So underlying the processing power, underlying the virtual warehouses, there is a storage layer. So storage layer you can think of to be a hard disk. Okay, so now we will have the virtual warehouses. Virtual warehouses consist of all these things. And then under the virtual warehouses, we have something called as, again, this storage layer. Okay, so we are talking about these two layers now. And these storage layer. Storage. These two layers work along with each other. Okay, so let me get this. And then let me do a double arrow. So there is a double arrow going on over here, because these guys can not just there is a bidirectional communication between these sources. Okay, so now your CPU will keep executing all these things. Okay, so with the very first instruction, let's look at the very first instruction. Employee table, you have to get this. Then your CPU knows that, okay, the location of the table in the storage. So it will go to the storage layer. Your CPU will access that specific location which is provided in the example, and then it will fetch the table from there. And then it will sell, okay, it will fetch everything in the RAM, for example. So RAM is something very common. So you know that, right? Whenever some processing has to be happened, that table first of all has to be copied from the storage layer into the RAM. So the very first level, so your my virtual layer will come. The very first instance, like, okay, it will go to this location where the table is stored in this storage layer. It will fetch that data and it will place it in its RAM. Okay, and then it will say how much data it will require. Then from the data which it has fetched from the storage in the RAM, it will allow that filter, and it will say which type of filtration has to be applied, and then how to get the final output. All the processing will be done over here in the inside of the executor, and how to display the output. And then finally the prepared output or the result is then sent by the executor to the virtual warehouse layer. Okay? By the virtual warehouse to the front end layer, right? So now let's mention over here. So the virtual warehouse takes all the instructions, instructions in terms of DAG from the cloud services layer, right? Services layer, sorry, not air, layer. Then it processes it one by one in the sequential order, because it's in the sequential order because it is already optimized, right? So there is no need for the virtual warehouse to apply it on mind on these things, because this is already optimized. There is no other way. There is no way these queries can be further optimized. We do not want to waste more time to the virtual warehouse. We think, okay, is there any better way to execute these statements? Your virtual warehouse does not has to rethink everything, right? It does not have to reorder these things. It does not have to apply any mind. Okay? It is a person who takes, okay, I have to do this. Okay, let me go to this location and take this table into my RAM. Okay, what do I have to do? Now I have to see how much data is to be fetched. Okay, let me put that filter. Okay, now I have been told this filter has to be applied and this data type has to be for this data type. Okay, let me apply this filter. And then how to get the final filter, final output. Okay, let me get this. How to display this. Okay, let me do this. So it will do all the instruction one by one. There is no re-optimization which is happening at this layer, and these steps are in terms of a tree. So it takes instruction one by one and it keeps on start then applying the instruction one after the. So then it processes the instruction. Then it processes it one by one in the sequential order. Okay, right. And then finally, once all the instructions are completed, right? Not the instructions are complete, then it returns the final outcome to the cloud service layer, right? So because now you can see that, right? So because the transaction manager is taking care of everything, your transaction manager knows. So your query result is created. So now what happens? Now what is happening? So we still have the query output. So the query output is ready by the virtual warehouses. So now what we have is that the output of the query. So we can mention query output, right? And now once the query output is ready, along with the query output, we still have these two things associated with it, right? So we know what is the query ID and what is the transaction ID associated. So now this box, these details now go to the transaction manager, right? Because your transaction manager knows what is the transaction ID, who asked that question, what is the query ID, because there could be multiple queries and there are, so every query has to be associated to a specific transaction, right? So this result is now returned by the virtual warehouses to your transaction manager, and then that transaction manager knows who asked that question. Then the transaction manager now goes all the way to the user, and now the user is able to see the output. Okay, this is how all the things happen at the very high level. Okay, still I am saying at the very high level because we have not deep dive into the virtual warehouses or the storage. Are we good? I mean, are we able to understand how the thing and how the cycle actually works around? Okay, we will talk about these things like we can have multiple virtual warehouses. We can how we create a virtual warehouse. What are the components of the virtual warehouse? How the virtual warehouses are created? What are the different ways? What are the different options? How many virtual warehouses we can have? So all these things we will talk about this, and we will also talk about the storage layer, how much storage we can have, how we are built for the storage layer, how we are built for the virtual warehouses. So here you can see that one very nice thing about the cloud services is that we have something called as pay per use model. Okay, so this is very important. So pay per use model says that you pay for only those services which you have used and you do not pay for the service which you have never used. That is so obvious, right? So this says that if you are sending 10 queries, you will be charged for how much compute is required for running those queries. And if you run one query, then you will be charged for whatever, I mean, how much it took to run that query. Okay, so we have a pay-per-use model. Okay, and why these cloud services are very good. We have discussed one thing. This is already we had, right? So you can say that, okay, this is still like my 10 years old, my SQL. Over there, I had all these components. I still had the CPU in my system. I have RAM in my system. I have cache in my system. I have the storage layer in my system, right? Everything was there in my system. So what is different over here? So over here, the difference is that the virtual warehouses layer and the storage layers are independent of each other and they can be scaled independently of each other, right? For example, so we had discussed yesterday, so for example, if you have one RAM or if you have a specific processor in your system and you want to scale your processor, then you will have to take your machine to someone. You will have to see which vendor is good, what is which, how would you will have a budget. Then on top of that, you will finally decide, okay, I instead of i7 processor, I will use i9 processor. And then again, we are restricted to how much CPUs you can have in your laptop. In your laptop, you can have only one CPU. You can increase the CPU with more cores, but you cannot have two CPUs or three CPUs in your system. So over here, I would mention like this. This is completely scalable. You can have 10 virtual warehouses, you can have 50 virtual warehouses, you can have one virtual warehouses, you can increase or decrease the number of virtual warehouses within our virtual warehouse Snowflake data warehouse account. So we are not restricted with anything. Okay. So if we can pay for it, we can scale up, scale down our virtual warehouses. Similar thing happens for the storage layer as well. So again, we discussed yesterday that we have a limited hard disk. We can have an external hard disk, we can save our data in the disk, but they are going to be very slow. So in this case over here, we will see that all these things are very easily scalable. Today, if I want 100 GB, I can have 100 GB storage. Tomorrow, if I need 1000 GB, I can even have 1000 GB. There is no limitation of how much virtual warehouses, how much compute layer I can have, how much storage layer I can have, there is no limitation. If I want a very big system, I can access for a very big system. If I want a very small system, I can also do that, and I can do it very instantly. I do not have to wait for anything. If I, for example, if I want 10 virtual, if I have 10 virtual warehouses right now and I want 15 tomorrow, I can do it within 1 minute. I do not even have to wait for hours, days. I do not have to interact to someone to the Snowflake Data Warehouse team. I do not even have to call them to talk to them, request them, raise a request, nothing like that. We can just raise a request and then we do not have a request. We can just go to the virtual warehouses website over there where we are already there, right? We are already there, and then we can increase our virtual warehouses. We can delete a virtual warehouse. We can do a lot of things. We can also make our virtual warehouses powerful, right? So we will see tomorrow what is scale in, scale out, scale in, scale out, and all these things, okay, around the virtual warehouses. And one good thing about these two layers, and that these two layers, although always interact with each other, but they can be scaled independently of each other. It is not like if I have two virtual warehouses, then I should have 100 GB of storage. When I have 100 GB of storage, I should have two virtual warehouses. There is no relationship between them. But if we talk about the numbers, there is no relationship between them. I can have two virtual warehouses. I can have 10 TB of storage. I can have 50 virtual warehouses. I can have 1 GB of storage. So nobody is stopping me, right? So we will deep dive into the virtual warehouses. So this is the very, very high level overview. Before moving on to the next topic, I mean, before ending to the session, I want to show you one more very interesting diagram. This is one interesting diagram and very popular diagram, which is for the Snowflake Data Warehouse, of course, because it shows all the layers at a very high level in the Snowflake Data Warehouse. There also something which I wanted to show you. Okay, so now this is again a different perspective of the Snowflake Data Warehouse. Over here, we can still see these three layers, right? So over here, the very top layer, we have the optimization, which is done by the optimizers. We have the transaction management. The management is can be transaction management or the user management or anything, okay? Because this is an entry point, so user management is also at the entry point, okay? So we have to have someone who is managing all the users, making sure that the user ID and password is correct. Because when we first of all go to the this URL, we are presented with the page where we have to provide the user ID and password. Then there should be someone who's validates this, right? We need someone who looks at the user ID password which we had provided and authenticates it. So that is why we have the management people. We have the management. It could be transaction management. So transaction management, we say it could be user management. It could be any management which is required at the very high level, okay, which is a requirement. So a user enters this from here. So it is a DOM you can think of, and someone enters from the top, right? Or you can also think of it to be a cell, right? This is how a cell looks like in our bodies. In our cell, we have celluloid, then you can think of it the nucleus, then there are some other things. We have mitochondria and all these things, if you if you recall your biological classes. And then on top we have the protein layer, which actually makes sure that nobody is allowed to enter our system, right? So this has a very nice similarity to the cells of our body, right? And then we have the transaction manager. So the transaction manager takes care of the transactions. We have the security personals. We have the metadata. Let's talk about metadata, why metadata is required. So the metadata, so we have seen, right? Whenever we do these things, whenever the query is parsed, right? So the optimizer needs help of someone called as metadata manager. So the metadata manager keeps tracks of what all objects are inside of your Snowflake data warehouse. It lists, okay, I have different tables. I have table employee, just the metadata, just an information, okay, not the actual tables. I have what all different type of tables I have. Okay, so it is just a notebook, okay, which just keeps track of every object. So I have an employee table, I have a customer table, I have, for example, I have the uh, any table. For example, I have the demo table as well. We can have any table with any name. Any side of the table, what are the columns I have? For example, in the employee table, I have employee ID, I have employee name, I have employee salary, EMP salary, I have the employee designation, for example, okay, EMP designation. And then if I go to customer, we have customer ID, for example, and also the data types. Okay, so it also keeps tracks of the data type. For example, customer ID is integer, and then the customer name is, for example, care of 20. So your table keeps track of, your metadata manager keeps track of all these things. what all objects are inside of your Snowflake data warehouse and what are the properties of those objects, right? So that is why whenever the query is being parsed by the optimizer needs help of the metadata manager so that it can actually, so here you can see that we talked about the optimizer needs to check whether the table exists, whether the column in that table exists, whether the syntax is valid. So to answer these questions, the optimizer needs help of the metadata manager to help it find out whether these things exist or not. Okay, so these things are actually answered by the metadata manager. So the metadata manager holds all this information, and your query parser has to refer to this metadata management to find out whether these things are actually, because the query optimizer is not interested in keeping all this information inside of it. It needs to refer to some system which maintains all these details, what all is available, right? So these things are done by the metadata. So this is the metadata. And then inside of it, we have different layer. We have the ad hoc, we can do ad hoc analytics. Now it is like everything is valid. The query is valid, it is secure, metadata exists, management is fine, it is been optimized. Then it goes to the next layer where it is now the virtual warehouses. So virtual warehouses gets all the details about the analytics, about the development, and everything is now sent to the virtual warehouse. This is the next layer, which is the compute layer. So everything is sent by the upper layer, and then it is sent to the lower layer, and then the lower layer now directly interacts with the storage layer. And the storage layer is actually storing all the data. So this is what we had seen, that the virtual warehouse get these details, how to fetch the details from the hardware, how to get the data, where the data is, and then finally those things are then done. They are searched, and then they are finally sent back to the user. Okay, so this is how it happens. You can think of it to be a U. So it enters here, it hits all these layers. If everyone is fine, it comes to the next layer. If everything is good, then it goes to the next layer, and then everything is fetched and then returned to the final layer. Okay, so here you can see that the very first layer or the outmost layer is the management and metadata. So it is independent management services which manage metadata, optimization, security, all these things which we have already discussed about. And the second layer is, we can say, that is the compute layer. These are multiple. So this we will see that if we talk about the virtual warehouses, we can have a single virtual warehouse, we can have 10 virtual warehouse, we could have 100 virtual warehouse, and each warehouse are of different sizes. We do not have just one type of virtual warehouse. We have different sizes of the virtual warehouse, and it depends on our need. We will also see how we know that which virtual size we want and how many virtual warehouses are required for our specific requirement. All these things we will take. So it can be multiple. So we can have multiple warehouses. These are independent, right? So if we create virtual warehouses, we will see that they are independent to each other. The virtual warehouses do not directly interact with each other. Okay? So they are independent. They are compute clustered, which who process the queries. Okay, so here you can see that. Let's process the queries. So they get the DAG from the above layer and they process the DAGs and they take the instruction one by one. They just do not apply their mind, right? So they are just those hardworking people who take the instruction one by one and they execute all the steps without doing any mess up, and then they complete it. And then finally we have the storage layer. The storage layer can be anything, right? This is the database. This is the database data set. This is the storage where everything is actually stored. All your tables, all your details, all the things, everything which you have created in the Snowflake data warehouse, they all exist in one place. So the database data centrally stored in the cloud storage. It could be an Amazon S3. So we are not going to create it. We are not interested in this thing. So one thing which you have seen here is that we do not have to, we don't have to worry about where the virtual warehouses are, where they are hosted. We know where they are, but exactly where they are, we do not know in this plant where they are. What is this? How they are managed, how they are maintained. And one great thing about this using the cloud architecture is that we get all the services up all the time. We get the virtual warehouses are always available. Okay? So then there is no downtime. There is no issues. If even if there is some issue with the virtual warehouses, they are fixed by the Snowflake data warehouse team. We do not have to worry about it. Similarly, if we go to storage layer, we can increase it, we can decrease it. We do not have to worry about how they are managed, how they are maintained. where it is specifically, we do not know all these details, but as soon as our purpose is fulfilled, as soon as I'm able to use the storage layers to store the artifacts within the Snowflake data warehouse, I'm able to access the artifacts within the Snowflake data warehouse, we are good to go. We are happy, right? Everything is good, right? So I guess it is time now. So I guess I have been speaking for a long time. Okay. So anyone, are we all good? Have you understood the very high level overview of the Snowflake data? Are we all comfortable? So if someone asks you to explain the Snowflake data architecture, I guess we should now be comfortable at a very high level.
That's what people like in the interview. If
Hmm.
someone will ask like how to summarize it.
Yes. So now you can give it, right? So from tomorrow, we will actually take a use case and then we will deep dive into this virtual warehouses layer and the storage. Okay, and we will also create a Snowflake data warehouse instance so that we can see how we can create the virtual warehouses, how there are a lot of properties around the virtual warehouses, how we can create the user, how we can, so everything you can see over here, we will see all these things one by one practically. So this session was to give you all the basic details of how these things work. And then we will go inside of the Snowflake data warehouse and then we will see how to do this.
Will you be walking us through to make an account for us? I'm sorry,
Yeah,
for Snowflake?
sure. Yeah,
Okay.
of course. And one good thing about this Snowflake data warehouse that it is available free of cost. We just need a valid email ID so that we can register to it. And then that's all. We need a browser and then just a valid email ID to create the Snowflake Data Warehouse account, and it is available free of cost for 30 days. And then there are some, we can use it for something around $400 worth of free usage, and we will be within that limit, even very less than that. So whatever exercises we will do, we will keep track of the consumption we are doing within that account so that we remain within the free time. Okay. So tomorrow, I mean, in the future lectures, maybe tomorrow we can also see how we can actually create the Snowflake data. Okay, and then we will go ahead. Okay, so are we all good?